Hi, everybody. My name's Brian Green. I come from Skydance. I'm going to talk today about the art and tech of creating characters for animated features. And I have this great quote from John Lasseter: "The art challenges the technology, and the technology inspires the art." So I've worked with John Lasseter for many years, and this has been one of our mottos that we've pursued over the years. Why listen to me? I've done characters for a long time. So at Pixar, I was there for over 22 years. And this is one of those ceremonies where they celebrate you being at the place for a long time, and my daughter Claire here is cheering for me. So this was my 20-year celebration. Here's some of the characters I worked on. And we get these Buzz and Woody statues that, are awesome. So some of my favorite things I've worked on. So I've worked on Monsters, Inc., Finding Nemo, Ratatouille, Toy Story 3. So I got to supervise as the character supervisor on these movies. And probably the favorite character I've worked on is Sullivan from Monsters, Inc. So I got to work on him way back in the day. And I also worked on Nemo. And I have a soft spot for him because I come from Australia. For my early years growing up, I grew up in Australia. I was actually born in a place called Tanganyika that doesn't exist anymore. It's now Tanzania, so it's kind of a fun fact for me. And I did all the things that you kind of tend to enjoy growing up in Australia, going to the beach a lot. And down here are some drawings I did as a teenager or as a kid. So I used to love going to the beach. I was inspired by everything. I'd bring back shells. I'd paint them. My dad was a big believer in that I shouldn't watch TV or waste my time creating cartoons. So it's irony that this is now my career. And I like to remind him at every possible opportunity. Over in the corner here is Steve Jobs. So I put him up there very early on in my life. My dad wired some money to the US because he heard about this brilliant guy called Steve Jobs making a Mac. And then on the far corner, this machine turned up, and I learned to program it. So I love programming, and I got to tinker on an early thing. And Steve Jobs is someone who had a big influence on me later in life, and I actually got to meet him and know him a little bit. So, enjoyed the beaches, went to school, went to Monash University, actually, at Monash University, I studied computer science and engineering, so a lot like you. I went there, and I was really passionate about, just learning about the universe. And my final paper was this thing called animating relativistic motion. And what it was Einstein had all these thought experiments in his head, and no one had visualized them. And so we came up with the great idea to write an animation system, visualize, using the laws of special relativity in the system, and see if all these equations and everything worked. And surprisingly, they did. So, I typed up my undergraduate project, and then my professor sent it off to this thing called OSGraph. And so I was like, oh, I get to present a paper. That's awesome. And at OSGraph, I got to meet this person, John Lasseter, who did this bouncing lamp. He came by to my talk and said it was great, keep going with your life. And I went to his thing. I was like, whoa, this bouncing lamp, he can make a lamp act. That's kind of fascinating. And I put a little challenge down here. So, in my university years, I was inspired by what I was working on. I was like, oh, I'm doing something that no one's ever seen before. So I kind of challenge you. Are you inspired by what you're working on? It's really hard to get started in life. You all come out of university, and you've got to get a job, and you've got all these uni fees you have to pay. For myself, I went to this place called Video Paintbrush, and they said, hey, our chief research scientist is away. We got a week, can you make a procedural flag that kind of waves? And I was like, oh, absolutely, I got a degree in computer science. So I sat down, wrote it in a day, and I was like, here it is. Like, oh, what are we going to do for the rest of the week? So then I got to play in all their systems and get to know everybody. And at the end of that time, they were like, well, we like you, we're going to keep you on. And so they actually kept me on rather than the research scientist, which was a little awkward. But anyway, got my little break in the industry, just through a little bit of hustle and good luck. And then it kind of worked and started learning my craft, There was a thing called RenderMan back then, which Pixar wrote, and so I started making this connection with this company over in the US. I was like, oh, tell me more about this renderer. I really want to learn about it. One night when I was working late, this company called Animal Logic called me up in the middle of the night. I picked up the phone. I was the only person there, and they're like, hey, is this Brian Green? I was like, yeah. They're like, do you want to work for the biggest company in Australia? I'm like, yeah. So they flew down. They interviewed me. I arrived really late, so they're all drunk. And then by the time I got there, they liked everything I said. So then I flew off to Sydney and joined Animal Logic, and my career kind of, took the next step. So back then, there was a dragon I had to make, and I got to work on that. I also got to work on this film called Babe the Talking Pig, and I started to get some connection with characters. So during this time at Animal Logic, this movie came out, Toy Story. And I went to the movie and I was like, wow, they're going to make a whole movie that's all 3D. So I went there and I was just blown away, like, how is this possible? So I was so excited, I went home and I typed in my resume, I sent it off to the US. I was like, whew, I got a good use for email, this is awesome. Surprisingly, they emailed me back and they're like, what's your phone number? I'm like, oh, I typed it in, and they called me and they're like, we want to fly you to the US and interview you. And what was happening at that stage was Toy Story was such a huge success, they had to hire a lot of people to make the next movie, so I was part of that hiring wave. So this is the challenge for me, this was new and excited me. It was a whole new field of 3D animation. And my challenge to you is, what new field is out there that you want to be part of, like something to reflect upon? So I flew I thought I was flying to Hollywood for this interview, and I went there and I was actually flown to San Francisco. So I was very disappointed. I went to Pixar and I was like, this is not Hollywood, this is some dump. It's like this horrible industrial complex with filled full of smoke, and we would all get sent home regularly. And when I arrived there, I was like, look at these wizards, at the things that they can create at this company. And when I got there, I was like, this piece of software is a pile of junk. I don't know how they made this movie. Everything was ugly. Like, the hair that they did was ugly, the cloth was ugly, the faces were ugly, even the building was ugly. And then I was just excited because I was like, this is a technical opportunity. There's tons and tons of challenges that you need. And so my challenge is, what problems do you see that you want to help solve? And that was for me back then. I was like, oh, I love this. They need a lot of help. So back then, Steve Jobs, got to meet him. He obviously owned Pixar. And during this whole hiring wave, he had this quote, it doesn't make sense to hire smart people and tell them what to do. We hire smart people so they can tell us what to do. And back then, they were like, he asked everybody, what do you need to do? And we're like, we got to create all this technology, and it's going to take time. So what he did was he needed to create some space for that. And so he went ahead and he said, well, he and John Lasser, we're going to go ahead and make this movie, A Bug's Life. It's going to be a lot simpler than the other types of movies. It's going to have these characters which are relatively simple. And then we're going to do a research short. It's called Jerry's Game. And in this research short, they're going to go ahead and solve cloth and hair, because these are two things that we need if we're going to create future movies. It's never been done before. This is the first time. So when I actually joined Pixar, I joined the commercial group. I've been doing that at Animal Logic. And I arrived, I'd sold everything, moved everybody there. And after the first couple of weeks, they're like, good news, we're closing down the commercial division. We don't have to use that division to make money anymore. I was like, oh, what's going to happen? Am I going to be sent back to Australia? And they didn't tell me anything, so I'm sitting around all week, nervous and the whole bit. And they're like, oh, you're really passionate about characters. Why don't you go ahead and join A Bug's Life and make some characters for that? And I was like, woohoo, this is awesome. I get to make characters on a feature. And it's the second feature that's ever been made. So I got to hop on. My first character over there is Slim the Stick Insect. And, we had all this new technology. I could tinker around, called subdivision, surfaces, and the whole bit. So I created that. I created a bird. I got to work on the main character. I worked really hard. And while all this was happening, there was this research happening on Jerry Short to solve these bigger problems. So solving all these problems, the next movie was this really ambitious movie. So we had the Gap movie, and then we had Monsters, Inc. Monsters, Inc. was very ambitious. Pete, the director, he was like, you know what I want in a movie? It's a movie full of monsters. They've got to be hairy. They all got to be scary. They've got to have fog everywhere, and this whole sort of thing. It's going to be hair. It's going to be cloth. And they're going to have tentacles. This is my vision. And we're like, oh, we've done one research short. How are we going to do the rest of it? So again, great guys, Steve Jobs is, what do you say no to, right? He's all about focus. He's like, well, you got to strip away from the story to the essence, and what you're going to solve with a hairy monster and a character called Boo with cloth. So these are lots of the things that we're saying no to. Originally, Sullivan was this guy that's hairy with tentacles. All these background characters over there. He kind of evolved to this little character down here at the bottom. And even that, we're like, no, we can't do that. That's too hard. It's got tentacles. So we ended up with this guy. He's like human. He's bipedal. And we ended up with Boo. And she's got a T-shirt. So cloth, hair, all of this for one movie. Near the end, we were able to evolve technology so we could go ahead and add a couple of extra characters. But even some of our tests, we threw into the actual movie. So we created a little hairball test. We're like, looks like a character. It's going in the movie. We got to fill it up. So, so the lesson for me from Steve was, can you do less and be excellent? That's what he's really saying. He's like, whatever you do, I want you to be excellent in it, but don't try to do too much because you're just going to be mediocre in a lot of things. So that was a kind of real life lesson for me. During this time, I also kind of learnt the art of what I was doing. So there's a lot of science, like Sullivan was very difficult with the hair, and there's a lot of them. But there was also the art. And one of the things we had to discover is we got these characters, and we got to go ahead and make them emote. So around that time, we're competing with a lot of movies with famous actors, and we're like, we have to study them. But we also met this guy, Dr. Paul Ekman, and he wrote this thing called FACS. He's an anthropologist, the facial articulation coding system, and he came and visited Pixar and talked about it. And it's like, we can break down what he's learned as an anthropologist and apply it to our animated characters. So we can tell the difference between a real lie, someone lying, and someone like telling the truth. What parts of the face? What are the visual indicators which allow you to figure out what's different? So we got deep into that, which was really awesome. This is what I call squash and stretch. So we have a baby, we got a head that's solid, and we got a mouth that's flexible. It's like a bowling ball on a balloon, and then there's Sullivan. So these are like the original drawings from Sullivan, like, this is how we're going to make the character, push all this feature around. So lots of study there. Afterwards, the movie came out. It was very successful. And the thing that was impressive about Steve was he got on the global stage and said, hey, you got to go see this movie. It's like a hairy monster never seen before. So he was able to get marked on a global level. But as a leader, he also came to the company and congratulated us all. We were all rewarded for our effort. And then he was also very personable. He went by and to each person who contributed to that movie, personally met with them and thanked them and the whole bit. And the other clever thing about Steve was he was like, you got to publish everything. You got to be involved in the research community. You got to have those connections as you go along. So he was like, but you also got to protect your ideas. Your ideas are important. So I'm seeing a lot of really intelligent people here. It's like you're full of ideas. Well, how do you share them and how do you protect them? The way he did this was through patents. So we started getting patents for ideas. And then he's Steve Jobs, he's very wealthy, so you'd give you money. So you're incentivized to get the patents because you'd get extra money in the paycheck. So I got a pile of patents, and that was his idea and kind of fantastic. So after Monsters came out, some extra movies kind of happened, and then this movie came out, so NEMO. So NEMO was probably one of my favorite projects to work on. And NEMO was kind of a process of reinvention. So we always made the movies to that stage in kind of a linear manner. And then in this movie, they were like, why don't we certify you in scuba diving? You can all go to Hawaii or rent a yacht, and you'll figure out how you want to make this very complicated movie. And we're like, oh, okay, sure, if it's for work, we'll go to Hawaii. Why not? So we went to Hawaii, and we were all sitting around in hot tubs, and we're like, well, how do we want to make this movie then? And we're like, it's all about focus. We need a character department where all the characters are made in the department. We need a sets department where the reefs are made. So they reorganized everything, and then from this, they came back, and we set up this department. I was very fortunate. I was invited to supervise the character department, and we applied everything from that research trip. So for me, that was a moment of pausing, like, hey, where are you in life? How can you pause? How can you reinvent yourself? Like, that is, you got to find space and time for that. So we certainly hit a point with these movies that technology was very simple to begin with, and then it accelerated very quickly. So I wanted to run through an example of hair. So when I arrived at Pixar, here's Toy Story, we got this awful plastic hair. There is no hair, it's plastic. Then we got Monsters, Inc., we're solving some research problems. We got Sullivan, he's got a lot of hair, maybe there's 3 million, it's all got to interact with each other. We move on, we got rats running in hair and being able to interact with it, so that was Ratatouille. And then Brave became like, we're going to do a movie with curly red hair, and curly red hair is really tough. And then all the way to like the Frozen series, which Disney did. And then during this time, people were working on these problems. And so I love this little thing at the end where they have this thing called a Sci-Tech Academy Award, and they recognize people's contributions over 10, 15 years to like hair research, which got us to the level where we could do type of Frozen 2. So this is simple. This is high school physics. You got a ball, you got a spring. You can multiply it by a huge amount, and then you get Sullivan. So, I'm sure anyone in here could do this. That's kind of where we began with. It was hard for us because computers weren't as fast as they were today, but we resolved it for this. Then we got to the stage of you need a doctorate level in math to do curly hair. This stage, we were also looking at reality. So we were like, hey, we've got curly hair. What we need to do is go look in the real world, see how curly hair works, put on wigs, play of archery. So we got Brave, the movie. We got Claudia over here, which is the hair and cloth soup. And I just love this image of her being like, oh, we don't know what to do, it's curly hair. And so she went out and filmed curly hair, and she did bows and arrows with her team and with other people. And then we have mathematicians kind of working on the math of this. Curl springs, length springs, the whole bit. Speaking of Claudia, so she became a good friend. She kind of reinvented herself and went down to Disney. So during the stage, Pixar became popular, Disney was distributing all the movies, and then Disney bought Pixar, and suddenly we're like one company, so we can share all this technology. So she saw an opportunity to go down to the Disney studios, and they were doing a movie, Zootopia, and they had to figure out, cloth with hair. So hair by itself is really hard, but what about cloth, and how does it collide with hair, and how do these two things react? So she was able to do this on the Zootopia with a big group of people, of course. And then the image on the far right is look at the attention to detail of every little aspect of this character. Like, we're surrounded by artists who have got attention to detail, and they go through and they make all these notes, and then you've got to figure out maths and arts and science and everything to hit all those notes so you can show it in the next review. So very challenging, but very satisfying. And then for me, the pinnacle with hair is probably the princesses on Frozen. So my friend Foam did this. And this is bringing everything together, like years and years of technology. So we got hair braids, which are moving like crazy. Let me go back one and play it one more time. Everything is orchestrated. The music is orchestrated with the hair, which is orchestrated with wind, which is orchestrated the effects to create this kind of like beautiful visual experience. So I put the slide in the middle. So we're in this process. It's very like all-absorbing. It's very demanding and the whole bit. And every now and then you just like got to pause and have fun. So like this is like just totally random. Pause and have fun and find time for that. And then a John Lasseter quote: "People who want to be creatively satisfied and having fun is being part of that." So John was great at creating an environment that was fun. This was just a fun day for me. We'd done this movie called Up, and we had this poster, and I'm like, what if Doug went and toured the campus, and everyone could meet Doug, and he would like interview everybody? So I went and took him to the producer of The Incredibles, and then he went to like the head of the company, and then he needed a medical check, and then he needed to do exercise to keep Doug fit, and then he went and ate candy in the cafeteria, and then he went and helped build a new building. So Doug had a busy day, so have fun. So hair went through this, like, after NEMO, this acceleration of technology. Cloth went through the same kind of acceleration of technology. So similar thing, we had Toy Story, it's plastic, no cough. We had A Bug's Life, like a Gap movie, and then Jerry's Game was this research. And then we had Monsters, Inc., and we did one T-shirt for Boo, and we like declared victory because we were able to do a single T-shirt. And then we quickly, the technology's increasing like crazy, and then we had Ratatouille, where we could have this cloth that's animated, and then, of course, Disney, after they bought us, and developed their own technology in conjunction with Pixar and created all the Frozen 2 and Princesses, which I think is the pinnacle of our stuff. So cloth, early days, reality inspires art, so we all learned to sew. I made my kids learn to sew. My son was made these little puppets and everything. We learned basic math, so we're at that stage. It's high school math. Anyone can learn it. And then for me, I was thinking back, at that time we're going out and learning practical skills and bringing them back to what we do. So I'm like, what practical skills can you go out there and help influence what you're learning in school? So here's an example of cloth. So you can go two ways. You can go to realism, and you can make things that are very real, or you can go to the opposite, and we call it complexity. It's like you can make complicated things feel simple and exaggerated. And so one great example of this is, of course, this character from Up. I really like this design from my friend Ricky. He's like, what are the basic shapes of the character? We got square, we got circle. Oh, this is what the characters should look like. Oh, let's put them into a movie. And then this is the simple shape language of the movie. So here's an example of Russell being designed. You have a typical cloth pattern that you do if you like to make garments. And over here we got this weird looking animated character who we have to go ahead and dress, and we pull everything around. Of particular difficulty was his shorts, and there's like a little flare. It's like, oh, it's very important we got a flare at the end, so we have to go through all these cloth patterns and figure out how we can apply fabric techniques to go ahead and create that. And then this is the guy. And then you can admire the flare in the corner of the shorts. A lot of effort put in there. And you can see this is, I think, some of the charm of what we're doing at Pixar is it's always the search for appeal. Like, what is appealing? It's not the search for realism. It's bringing that in to give us the tools to find appeal. So that's the bottom line. And this looks exactly like someone at work. So if you're walking around, you double take because there he is, walking around the corridors, Peter Stone. And then cloth evolved. So we had like appeal in one direction. Now we have appeal in another direction. So we have Griselda doing these beautiful pieces of art for Princess. We have this thing called Marvelous Designer, which is a piece of software that any of you can like download and use. And you can go ahead and make garments using panels. So you can make garments for Halloween or for whatever you like. We do it for CG. There's practical art skills involved in whatever you do. So, we'd go ahead, use this piece of software, Marvelous Designer, would create something. Griselda would come and draw all over it. So Griselda is this amazing artist who can go and use her practical drawing skills to kind of push us in a certain direction. Here's some of her notes. Then there's a lot of like technical kind of mathy stuff. If you create a virtual garment, how do you not make it fall down? You got to do constraints. What type of constraints? These are kind of the mathematical constraints used to make the garment work. And it's tedious. You got to create a lot of constraints so the thing doesn't collapse. And you can create the volume, and you can create the bustle, and all these different things. But the end result is, to me, this very beautiful kind of piece of like the skirt that has volume and can act, and you have technical animators that go in and synchronize that with music, and it's, it can be amazing when it all comes together. And then for me, so I'm introducing all these different fields. There's hair, there's cloth, there's rigging. For me, cloth was one of the fun things that Pixar did, so it's like, how can we bring in reality to inspire what people are doing on the computer? You're in a dungeon, you might be working, but you need to get out of the dungeon, you need to see what's real life. So things that we did at Pixar was we went to the circus, and we met the people at circus, and they gave us keys on how to make, circus costumes. Halloween was fun, so we'd all use our sewing techniques and lessons to go ahead and create costumes. That's my son Lucas, being a barbarian. And then Sonoko over here, she'd always win the costume contest because she was one of the best people in the cloth group. And she would design, using the software, this most amazing costume. So we love Sonoko. And his friend, who was she was always going out, we got to go out and meet, people from ballet or theater or whatever, and we'd all go on these amazing expeditions with her. So it's a big kind of discipline and all engrossing. And then another reminder, have fun. So at work, at one stage, after working really hard, we're all exhausted, they converted all of work to this golf course, and you could go around and do 18 holes for all the various offices and stuff. And, you have fun at work, but you also have to have fun at home. So I thought you'd appreciate this, those people who do engineering. This is a backyard Tesla coil I built to see if I could cook a marshmallow with, 110,000 volts shooting across the yard. So that was kind of a goofy thing to do with my sci-tech kids. And then lastly is for this talk is rigging. So rigging is going ahead and adding all the skeleton and the muscles to a character, and then giving animation the controls to give an animated performance. So that's that loop. Remember earlier I was like, Monsters Inc. was too hard to do tentacles, and we did cycles. Sometimes we work on problems for a long time. So all that technology about doing tentacles, we had another opportunity to do it on Finding Dory. So we have this guy, Hank, very complicated. He's got simulation, all this type of stuff. But the problem for Monsters Inc. hadn't gone away, and having people with technical aptitude to keep these problems in their back pocket, and then when the movie appears later, they can solve it, I think was one of the gifts that Pixar had for us. So here we have, the character. Here's the controls for animation. There are all these splines, so they can go ahead and interact and manipulate them. You can see these jiggles, so the simulation department jumped in and resolved collisions and all the secondary motion. It's probably one of the most difficult characters I think we've done. And then, of course, when it all comes together, it's this kind of beautiful, lit moments in the movie. And of course, he had to be visible and all these extra things. And of course, rigging evolved from, hey, we're just making the characters move, to like, hey, we want the character to move and you want to see the muscle flexion. So the thing on the left is what we started with. The thing on the right is when we add all the extra muscles and secondary dynamics. Everything, of course, has to get more and more complicated. And then this shot is interesting to me because we're adding all these different disciplines that have evolved out of Pixar and Disney. So let me play it one more time. So we have a character which has hair and cloth and muscles, skin simulation, kind of walking through rain, which is effects for just one single shot. So that was kind of like, hey, we went from a t-shirt all the way to being able to do this really complicated character. So, I'm talking about all of this. I think there's a general reminder that it's not one person who does it, it's a team. And I was very fortunate, I had a great team. But it's also for you, like, who are your friends? Who's your team? Who are the people you can work with to do great things? And I think part of this journey is, you've got to recognize them, you've got to embrace them as you go along. So Disney Animation, here's a company, it's huge. You make a lot of friends along the process, and you make most real friends. You also make a lot of virtual friends, which I enjoyed. And I guess that's it. Thank you. That's it. I think I have plenty of time for questions, since I talk too fast.
So, does anyone has any questions? Okay.
Hi.
Hello.
Hello. I'd like to make a question about, you said about the facial, and you
Yes.
said about the skeleton thing, but I didn't get it exactly, like, how people like behave in a walk, in the dynamics of walk, because in terms of characters, there will be a lot of different types of walk, in my opinion. For example, the other one, like from Up, the Carl Fredericksen, it's a kind of walk like, in a strict way. So it's totally different from the guy from
Right.
Yeah. So how is it made like this? You think about the personality of them. You think about what are the other concepts you need to use to understand this type of way to walk.
Right. So I think the question is, how do we anthropomorphize all these different characters? How do we learn from one set of creatures to another on how to create emotion? And the interesting thing about how we're created, of all of the various creatures is, we have 3 muscles in the eyebrow that go up and down. That's what the facial articulation coding system goes ahead and breaks down for us. So we can find similarities between all the creatures we create and create like a common system to go ahead and get them to emote. So part of the fun is like, oh, I got Bruce the shark, and he's got this big smile, he's got his brows that come up, and we've discovered that we can get the same amount of expression out of Bruce the shark that we can as, a human character. And it's because physiologically we're all actually built similarly. Like if you think about a giraffe and ourselves, we've got the same number of joints in the neck between us, and we're like, oh, how's that possible? It's because there's more similarities than differences. Of course, the fun thing is like, is the character evil? Is it, what's the motivation behind it, and how can we push the stuff we do to reveal the motivation? And I think that is like, then we start building it into the design of the character. You can make it a little more sinister. Earlier on, when we showed Hopper at the very start, he was in A Bug's Life, we used Steve Jobs as like our reference. We're like, yeah, he's like head of all the grasshoppers. Steve Jobs is the head of all of us. We'd like study Steve and try to like make Steve a grasshopper. So we do go reference all the actors. So we go and we're like, oh, that's the actor. What's their expressions? How can we bring that into the character? How can that influence the design? And that's part of the kind of fun process of discovering these characters within this for animated movies.
Thank you.
Yeah, but if you look online for Paul Ekman, facial articulation coding system, he's got a whole training system where you can learn micro expressions. So I can look at someone and it might be a flick of an expression and you'd be like, oh, that person, you know, is thinking this. And it's fun. You can train yourself up and, you know, but you've got to stop staring at people like, what's that micro expression? That just makes you creepy.
Thank you. More questions?
I wanted to ask you about how you transitioned from studying engineering to working in animation. I mean, it's still a big jump. How did you transition?
Yeah, so I was doing my degree in science engineering. I always loved the art, so I'd do like painting classes at night. Back then it was a stage of invention, so they were like, how can we create the tools to do this? So when I went to video paintbrush, I was a research scientist, and so the question was, we've got to have a fractal mountain. Let's go and look in chaos theory and create something. But ultimately, it had to be a beautiful kind of fractal mountain. So it was the ongoing development of my art during this period that allowed me to creatively, you know, hit the targets, train the eye to do all this. Bottom line, I think it was just passion. I was like, this whole field was emerging of computer animation. I had the technical skills. I could jump in and use those skills to go ahead and do the art that I wanted to do. So I'd call myself more, I'm stronger on the technical side than the artistic side, but the art side was the passion that kind of drove it all. And it's also like, you don't have to bottle yourself in. Like, my dad wanted me to be an accountant, and I'm like, maybe I'll compromise with, you know, science engineering, which I love, but it's not accounting. And then I discovered science engineering gave me the tools to go ahead and help make these movies, which people hadn't made before. So that was kind of my opportunity. And, you know, I have a kid, he's like doing AR and VR and pioneering his own way into creating these experiences I'd never imagined. So it's kind of finding a passion a little bit, I think, and pursuing that. And not being, people say if you're a scientist, you can't be an artist. And it's like, no, you can be whatever you want to be. So it's just not letting those boundaries kind of box you in, I think.
Hi. You talked about the challenges of creating like hair and cloth and facial expressions. What do you think are the challenges at this moment that animation can't create right now, but is trying to?
Right. Yeah, the challenges for the moment is fascinating because we did this big push in animation to things looking more real, like more detail, more everything. And now we're trying to jump to like, oh, it all looks the same, right? You go see all these movies, you can't figure out which company makes it, it's all using the same software. So people are trying to jump to like something new and fresh. I think the Spider-Verse is really interesting because it suddenly jumped to this like two-dimensional, three-dimensional, you know, Mitchell and the Machines is another jump. So I think it's using these tools to jump to a new place artistically that we haven't seen before. And everybody's out there trying to figure this out because it's all became, well, as I'm saying, looks similar to me. So yeah, great creative challenges out there, I think. And, you know, the stop motion, that came back. I was so grateful, stop motion, I love it. Like, oh, went through the full resurgence to like, it kind of vanished and now it's back and you can see things move that are handcrafted, which I think is awesome.
Does anyone have any more questions?
So I grew up thinking that designers at Pixar, at Disney were awesome and that they have these great ideas. And as I get into this field, I realize that computer scientists are behind everything, right? You get mathematicians, you get physics involved, and you're telling me that the octopus didn't make it to the movie because, you know, you decided that you didn't have the technology, all right, to get him into the movie as you wanted. So my question is computer science the new design now?
Sorry, say one more time.
Is computer science the new design?
Yeah. Yeah, the question is how can we push the new design, like the scientists make these tools that allow us to push. For me, the current fascinating area is like technical animation. Like if I got this incredibly complicated garment with hair, with dress and everything, and I've got music, how do I synchronize those two? And what kind of technical chops do I need to get all that simulation and physics and everything to give this like, you know, Disney animated performance? But it's everything, right? We need scientists with good eyes and people with good eyes communicating their ideas to scientists to kind of push things forward. And that's what I enjoy about my job, I think, a lot, is there's so many varied people who are so successful in their own field, but they're inspired by the big project. So we all get together and like, we need everybody to make this these days. Yeah. You know, right now I'm at Skydance, I'm like, we need people with Houdini skills that can do hair grooming, because that's the combination of software that's out there, that's a strong technical person with great eyes. So if we go ahead and make these characters, I'm like, it's, you know, I'm kind of excited for you, because there's just so much opportunity out there if you're willing to go and seek it out, and you can seek your passion. And the whole world's opened up now that we're all, pandemic sent us all home, and now we're all used to working on Zoom and can work remotely. It's just like, we had this analogy, like we all got up during the pandemic and then switched seats and then sat down and there was 5 more seats. And we're like, who's going to fill the seats? You know, it's, the world has become smaller and bigger.